So let's solve some more simultaneous equations, one with a quadratic, one as a linear equation. So for the bottom one, we have y equals 2 plus 3x. So we're going to substitute in the y on equation number 1 for 2 plus 3x. And equation number 1 is the equation of a circle with a radius of root 40. So I'm going to write out the top equation again, but this time I'm going to pop in a bracket, 2 plus 3x squared, and that equals 40. So I'm going to do some side calculations because I need to expand that bracket. You can possibly do it in your head, but in your exam I would clearly do all the steps so you don't miss something. 2 times 2 is 4. 2 times 3x is 6x. 3x times 2, that's another 6x's. 3x times 3x is 9x squared. Now I'm going to put that in order, and now I'm going to add those two terms together to get 12x's. So I end up with, drop down the x squared. I have 9x squared, I have 12x, and that is going to be add 4 equals 40. Now get everything to left hand side, and I'm going to combine these two terms here. So I have 10x squared plus 12x, 4, take off 40, so minus 36, and that equals 0. From here, always look to see if you can simplify. So every term has a factor of 2. So I'm going to divide it by 2. It just simplifies it down. So 5x squared plus 6x minus 18 equals 0. Now this will not factorise. You can give it a go. It's not going to factorise. So I am going to use the quadratic formula. So our quadratic formula, we know, is to get x, we need minus b plus or minus the square root of b squared minus 4ac all over 2a. So let's substitute that in. So minus b, so that's going to get us minus 6 plus or minus the square root of, so 6 squared, so 36, minus 4 times 5 times negative 18 all over 10. So pop that through. So we should get an x value of 1.390 and an x value of negative 2.590. And then the corresponding y values, you're going to do 3 of these and then add 2. So you get negative, and that can't be right. We're going to get 6.170. Do the same with this one. So we want 3 of those and then add 2. We get negative 5.770. Have a go at these. I've got the answers on the next slide. Okay, I'm going to stop this video here and make a third one for a different set of simultaneous equations that looks something a bit like these and these.